start today by talking about AI failures. But before we do that, something fun to show you. We have our AI news of the day. And this is particularly near and dear to my heart because today in Scientific American, there was a paper talking about how 300,000 kitty litter box visits were analyzed by putting basically a scale and a little motion sensor on the litter box. And you might think, how dumb is this? Well, it's actually fairly interesting because from that and the weight measurement, you can actually diagnose lots of problems with cats. So this particular litter box, which is called the Petivity Smart Litter Box Monitor, tracks the cat's weight and any excreta and any motions. So if the cat gets in the box and turns around 2.5 times, you know that that's kind of normal. If it turns around like 10 times, you think, wait a second, what's going on? And so they identified 39 different litter box behavior, which turn out to be useful for diagnosing things like diabetes. Because you may not know this, but a cat with diabetes will use the litter box like every 30 minutes all day long. And that's a big signal. And I know this because I had a cat with diabetes. And yes, I gave it insulin twice a day for the last 10 years of its life. So this is a kind of very clever AI application. And because cats have slightly different weights, it can discriminate different cats in a household. So this is an interesting sort of medical AI and medicine diagnostic tool for cats. And to stay in the cat theme for just a minute, this is a product that you can buy in Zurich. I found this when I was out walking around through Zurich one day, and I saw one of these really interesting little cat doors. And it does two things. The kitty has a smart tag, RFID tag on their bracelet, on their necklace. So it recognizes the cat. The second thing it does is it has a little camera, an infrared camera, so it works in the dark. And they built a classifier like we did the other day. Remember that? They built a classifier like that so it can recognize when Kitty comes home with a rat or a mouse or a snake or a fish or a piece of string, and it will unlock the door if it's a piece of string. It will keep the door locked with a little red light, training Kitty to bring home snakes or dead birds or whatever. Right? So this is a very clever thing, and it's the kind of thing that you now know how to do. This product space is closed. I mean, don't bother with it. But it was a very clever idea. And then, as far as I can tell, they own that market now, at least in Europe. And there's two students from the University of Zurich. I also want to spend a couple of minutes giving you a little bit of feedback from that long ethical we did the other day. So first off, thank you, everybody, for filling it out, because we got a bunch of responses. The compliance rate was really high. It was like 95%, which is great. And a lot of very useful and thoughtful responses, which I also appreciate. So there were 5 key results here. Remember, there were like 9 different questions. First off, people responded strongly to the bias in data thing. It was a real concern for everybody. So I'm aggregating everybody's results together here. People also, privacy violations, everything from collecting personal data without consent to using it beyond its intended purpose. So informed consent becomes a really key theme throughout all of your responses. Now, the question really is, what is informed consent? How do you get it? I mean, you could ask for it, but what does informed mean? Do you really understand all the implications of saying yes to this? Of issues about copyright, fair use of data, data protection, and so on. We'll actually return to this topic later in today's lecture. So here's a little kind of a summary. Remember the questions about asking about could AI companies use data from your email? And the answer was, according to you, no. You can ask me, and if I say it's okay, then yeah, sure. But it's a strong no on all these things. In particularly strong no for taking purchase behavior and using my purchasing behavior for the model. Now, everybody responded negatively to that, but I'm afraid that cat has left the barn. That's already in use. There's nothing you can do about it at this point. The last couple of questions, remember the question about should a company repair a thing that failed, a crash car crash that happens at the rate of 1 in 100,000 hours versus 1 in a million hours. Remember that? Okay. The interesting distinction between this, question 5 and question 6, was that the number, the denominator, 100,000 versus 1 million, changed your answers. I'm not too surprised by that, but because people said 100,000 hours, company needs to fix that. Absolutely have to fix it, not a question. 1 million hours, that's, that's a long time. Maybe we don't have to serve that. But people commented on a company needs to make good, judicious use of its resources in deploying where to fix these problems. Okay, so thank you for that. I will, if you're interested, I will send out a document later this week with sort of a full analysis of it. And if you're interested in how your colleagues think about these ethical dilemmas, read that. Okay. So let's get into the mainstream of today, which is designing for AI failures. And what I mean by that, and why this is a topic, because, Karen, did I comment? No other HCAI course in the nation teaches AI failure, as far as I can tell. It's only here that you get the good juice. It's only here we tell you the reality of what's going on. And what I mean by that is even the best AI systems can make mistakes. So designing and building and deploying a successful AI system relies on you handling failure. Because whatever you build, it's going to fail in some way. What do you do about that? What do you do? So here are a couple ideas, right? The outputs may not, when we get to agent systems, we'll have to talk about this when we visit this. But basically, output should be suggestions, not necessarily commands. Users should be able to understand, override, and correct the AI and give feedback, which is something a lot of AI systems do not have. And the AI system should be transparent about what it can and cannot do. So the number 4 there, which somehow wandered off the end of the screen, is about giving feedback. So I love this comment by Paul Virilio. We said, the invention of the ship was also the invention of the shipwreck. The reason that's relevant here today is that things fail in very particular ways. So the Paris train stations used to go through the end of the train station. Your horse does not do that. So implementations of different technologies have stereotypic technology-enabled ways to fail. So if you understand failure modes, you can start to figure out how to design around that. You can understand ways in which we can do better. Oh, sorry. I didn't just throw a blue screen. Has anybody seen one of these in a recent, like last year? You've seen them, okay, but not in the last year, right? Well, this used to be, this was like on the Macintosh, you got the spinning beach ball of death. It's the same thing. Something really, really bad happened, and all you can do is restart. It's all you can do. And there's a wonderful error down here, which is useful only for systems engineers, right? It's in hex. I want for us to think about today how AI systems can go wrong, and how do we even know when they're going wrong? How does the user know when something's failed? How do you pick up on that? And what can we do as designers, system builders, implementers, figure out ways to reduce the number of errors? So, designing for AI failures encompasses, first, understanding what's a failure. So, a failure for the human is basically when it's doing something you didn't expect or something that is categorically wrong. So, an actual error is one of these clearly incorrect things. The self-driving car drove through a red light. That's a real error, as opposed to something where it's just, I didn't expect that. It's kind of interesting. We'll talk a lot about misalignment. So alignment of expectations or alignment of goals is making sure your AI system aligns with what humans want. And there's a whole bunch of woohoo stuff about this, but for us, it's a very practical thing. How can we be sure that what it's doing is the same as what we want to have happen? The last category of this is a failure is also just inexplicable behavior. I don't know why it's doing that. So there are lots of AI failures. Here are a couple of my favorites. Taco Bell rethinks the future of voice AI to drive-through because it didn't work out. It didn't work out. For example, one person drives up, orders a taco, and the bot keeps ordering more tacos. And when it got up to 250 tacos, and the person is screaming, "Stop, stop, stop," you know you have a failure. Okay? And so it's also, it doesn't help when there are trolls, maybe high school students who come up and says, "I'd like 18,000 cups of water, please." That's a legal request. You shouldn't, the system probably shouldn't do it. But so there's a lot of things like this where you and I would say, "Oh, that's just common sense." The problem is common sense is difficult. Peter and I have been in this game for a long time, and the classically hardest problem is making systems have common sense. Now, lest you think this is limited to Taco Bell, McDonald's had exactly the same problem. If you click on that link, take you to a different document, a different story, same underlying problem. They could not rely on the voice system giving them correct orders. That's a kind of failure. So let's talk about just basic failures. So I went to UC San Diego long ago, and I saw this and I thought, wow, that's so broken. As a UX person, well, what's wrong with it? So there's a big notice in the upper right corner. I don't know how to click on that. Click on here to make this happen. Okay. It's not summer when this was being shown, right? So those office hours are totally wrong. And then there's a failure of an applet to run inside the iframe. So these are all manifestations of very simple system programming failures. This is not AI. But we can't get this right. So when's it a bug versus a fundamental flaw? Because one of the things that will happen is that people will point out in an AI system, "Oh, that's just a bug. I'll fix that in the next release." Versus an underlying fundamental misunderstanding of what AI can do. So part of the problem is the systems will present answers that look really good. And this happened to me. I was in Newark Airport. I was staying at a hotel, and I said, "I want to get to the train station." So it says, "Dan, just walk on the little dotted blue line here, and you'll get to the train station." And I started walking that way until the armed security guards threw me out. That was not noted on the map, right? They had guns, so look, I was not going to mess with them. That's a legitimate road with no public access. Is it just a data problem, or is it a routing problem? I mean, obviously there's a data problem here. A fundamental problem with a lot of AI systems is keeping a congruence between reality and the model. So in this case, the connectivity model of the route of the map said this is connected to that. The graph algorithm says, if you go from here to here to here to here, you will get to the train station. But it's even deeper than that, because you can walk from there to there until you get stopped by the armed guards. Big thing number two, that cemetery, it's not there. That's a fake cemetery. It's a parking lot. Big problem number three, up there near Haynes Avenue. It says you can walk up there to get to the train station. No, you can't. There's a 15-foot fence there with barbed wire at the top. So there's a misalignment. So the reality does not allow for a solution here. It doesn't matter how smart your AI is. If it doesn't have an accurate model, it can't figure its way out. So here's another map. It looks sort of similar. This happens to be in Zurich. I wanted to go from taking the tram down there. So I'm sorry, the tram doesn't do that. That's a completely impossible path, because that red line, that 45-degree line down there, passes through the middle of the building. So the map is fundamentally wrong. So we've talked a little bit about hallucinations before. And here's an example. So I asked ChatGPT to give a short biography of the computer scientist Daniel M. Russell, blah, 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 blah. Cool. Produces this. And I read this and think, wow, this is awesome. Although beginning of the second line, what begins, I got my bachelor's degree in computer science, University of California, Santa Cruz. Well, that's not right. The second phrase is correct, Rochester. But then I began my academic career as a professor of computer science at the University of Waterloo. I've never been to Waterloo. I don't know how I was a professor there, so I actually edited this. As you can see, a lot of it is wrong. And I'm sure I could go figure out what the sources were, blah, 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 blah. Because there are multiple Daniel M. Russells, many of whom are in academics. And so what you're seeing here is a conflation of different identities, all pushed together. But it's close enough that if you weren't checking, you'd accept this as truth. I can go on for hours just showing you bug after bug after bug. But here are 3 examples of hallucinations. The very first one is translate the following English question into Spanish. What's the capital of France? And the output is the English text, the capital of France is in Paris. Fundamental not understanding what the person's wanting. Or the second one is about the origin of the Nile. Where does it start? It doesn't actually start in the Great Lakes region. It's more complicated than that. And then fundamental problem here, the very last one, where it just got the math wrong. Can't do division correctly. Now, math handling on LLMs has gotten better, but you still run into these kinds of problems. Basic issue. People hate fact checking. Hate. And so when you get a plausible piece of text like this, people just tend to accept it. So AI failures have a couple of interesting properties. We now know that AI recommendation systems, for example, can be high stakes or low stakes. A low stakes recommendation would be, I think you should listen to this piece of music next. A high stakes one would be, I think you need to serve 20 years in a federal penitentiary for federal prison sentencing guidelines. There's a tool called Compass, which we'll talk about in more detail later, right? All of these AI systems now start to vary a lot. If you're a designer, you need to understand, is this a high stakes or low stakes thing? More importantly, is it high stakes for you or for the person using it or for society? Remember the tripartite division we had earlier? App, person, society, right? You need to allow people to have ways to understand what the system is doing in such a way that they can recognize when it's an error. And hopefully give people a way to deal with that error when it happens. So here's an interesting area you might not have thought about. You probably have done a little vibe coding, right? Where you use a large language model to write 2 pieces of code. And so whenever you get a new system, a new tool to build code, a new AI widget, it opens up new opportunities for bad guys. And here's an interesting attack surface that I didn't think about. So suppose you have this large language model that's helping people write code. A malicious user on the left says, I'm going to write a piece of code, and it generates an error saying package not found, say, for something that does a natural language query processing thing. Cool. It says it calls this package XYZ, right? What bad guy could then publish a package with malicious code called XYZ, knowing full well that someone else is going to ask that same question. And then there's bad, malicious, tainted XYZ package out there, which then gives him full access. See the problem? So in classic internet world, there's this thing called domain squatting, where you can buy a domain name and then sell it to the next guy who really wants to use, jobs.com or something like that. You can also buy up domains and then repurpose them. So for example, for a long time, you know that the White House website is called whitehouse.gov, right? For a long time, if you went to whitehouse.com, it was a porn site. They were domain squatting on domain whitehouse.com. Because a lot of people will type in whitehouse.com and porn. Mistake or clever use? Well, in this case, this is very much analogous to this, where somebody's saying, here's a package that I bet you're going to try to invoke. And I'm going to grab it first and put in my code. There are also AI applications like this that will identify trees or birds or mushrooms. And this particular package, it's a slide missing. This particular package has a very high rating. It's like 4.9 stars out of 5. Think to yourself, how much do you trust this? How much do you trust a mushroom identifying app? It gets 4.9 stars because all the people who would have given it fewer stars have died. This is the ultimate case of survivor bias. So you should think about this carefully. Yeah. Oh, yes. Correct. Skydiving services would also have the same kind of survivor bias, right? You know, it's one of those cases where at first you don't succeed, skydiving's not for you. Yeah.
For an app like this, it could have like maybe like a 99% success rate, but if you're a frequent user of this, it leads to wrong points for you.
That's right. So even a high probability of accurate identification can still kill people. That's right. So what would you do as a UX designer? Well, you probably want to say here, caution may result in death. It's like all those advertisements you see on the TV, they give you a drug, and here's the 29 different ways you can die using it. Same thing here. But you need to make that super prominent, not make it 2-point font, read by a guy at 100 words a second. So you need to disclose that. Here's a more mundane, less fatal kind of view, where here is the Google Lens, and I'm using it to identify literally a bush outside of the office of Google. And I took this picture, I thought, that's great, what is it? So I did Google Lens, and it says it's a toilet. Now, I'm enough of an amateur botanist to know that ain't right. That's not a toyon. Toyons, just so you know, they grow everywhere. You have probably passed 100 toyon bushes on the way here. They don't have berries like that. Part of the problem here is you see the little bracket? That bracket is telling you what the input focus is for this identification, taking into account a little piece of one berry and a couple leaves. So if you then move the focus a little bit over to just the berries, like on the left-hand side, it says, oh, you got a lychee. That's not a lychee either. So you're striking 2 out of 2 now. If you change the focus yet again to get a larger image, so you can get the tree, the branches, the leaves, and the berries, you will get the correct thing. It's an arbutus, a strawberry tree. And in fact, they are edible. They just taste terrible. I know because I tried one. Point is, here, Google Lens is saying, I'm looking just at this little tiny part of the image. It's giving you some visual feedback. So if you get something that's incorrect or just doesn't line up with your expectations, you can debug it. But how many of you would have said, oh, that's a toyon plant? Because I've never heard of toyon, and it kind of looks, it has kind of red berries and leaves that kind of look like that, just not those red berries and those leaves in particular. General point, visual identification, especially of some plants, mushrooms, small shrubs, grasses. Let me tell you, getting any visual identification of a grass that's getting a species from it is damn near impossible. Very, very hard to do. Don't trust it. So what's different about AI failures? As an expert user, you should understand what the capabilities of these different AI systems are. Don't trust mushroom identification. be very cautious about plant identification, high stakes versus low stakes? Or how about, this? How do you know, is this a successful run of Google News, which is giving you a recommendation of news items to read? How would you know? There are 1 million articles published per day in the global news space. It's theoretically giving you these as the best ones for you. Go ahead, prove me wrong. How would you do that? You can't. So what happens is that it's more than just a UX. It's more than just whatever the placement of items is on the page, but there are all these ranking changes that happen. And behind the UI is a seething mass of news stories that get published and pushed and withdrawn and modified. And the data changes constantly. Also, your feedback will change the behavior of the system. Do you know how? So this kind of stuff changes a lot over time. And we as experts have to understand this. So here's a query for the search term oranges from 2014. So just, not that long ago. You got, no surprise, oranges. If you do it now, you get the corporate website of Orange, the company. It's very, very different. Is that okay? Is that a failure? Because I expected fruit. I didn't expect a corporate webpage. How would you tell it? Here's another example. I wrote a piece of code that, given a list of 2,000 computers, used Gemini to actually find a website dedicated to their music. And I will tell you, all this stuff on the right-hand side, it's all wrong. The name of the composer is in column A, the website and the comment is in column B, and every single one is wrong. But looks good. I will tell you, all of those websites there are all 404s. They don't exist. I wrote another little function that did the lookup for that domain and returned true or false. So it was very easy for me to fix it. But if you don't check, you don't know. Again, a lot of AI is super confident, even when it's giving you BS. 4,000 entries, a lot of it was just plain wrong. So when you're dealing with AI systems, it's one thing to notice when they fail. It's another thing to know ways that you can interact with them, right? This is an HCAI class. How do you interact with AI? What do you do? So here's a thing from Google News. And what you may or may not know is that when you roll over the top item there, it actually changes the UI like that, okay? Roll over, it changes it from text to a link, okay? And notice anything else? I would side comment, this is terrible UI design. Watch what happens between when you roll over, watch, boom. You got a whole bunch of new buttons up there. You see that? You get, that converts to a link, and you get all these buttons over here. Right? Everybody knows what that little triangle means, right? It means little 3 dots, the hamburger menu gives you more options. What is the sort of chevron-y thing looking here? What does that mean? Anybody? What? Right. How do you get to bookmarks? Right. That's the big problem. Everybody knows the bookmark. How the heck do you get the bookmarks? I don't know either. And I work there. And I have no idea. So the bookmark feature is in general not, shall we say? Okay, so if you click on the hamburger dots there, you'll get this submenu. So you can go to see the full coverage. You can go to space.com, which is the domain that's hosting this article. And then you have 3 options. The hide all stories from this, more stories like this, or fewer stories like this. What happens when you click each of those? Well, the hide all stories gives the system clear feedback. Just space.com. Got it. Good. More stories like that. What do you think happens? I imagine that a parameter somewhere gets clicked up by like 1/10 of 1% or something. And if I get fewer stories, it goes down by 1%. What happens if I click on it 5 times? I don't know. No idea. And it doesn't tell me. It gives me no feedback. And don't do that. If you're going to have an interactive widget that's going to change the recommendation algorithm, tell the person what it's doing. Right? Okay. What's a failure? How do people know? So people complain about things like it's hard to type on mobile, and I want the same to be mobile and desktop. Remember the smart reply thing we talked about a couple days ago? Smart reply basically creates a reply for you using smart AI based on the content of the email. So remember we had that sensitivity, expectations, and failure model analysis before? Here's a thing that people say all the time. I see it's creating a reply for me. Is Google reading my email? That's the thing people worry about. It's a concern. If it is it giving me accurate expectations? Yes, I think it's actually, I've done it a few times and I've seen what it's done. It's great. If bad, you can just ignore it. Graceful failure. So the concern about user sensitivity probably should be addressed by the UX design. Something like, no, Google is not reading your email. We're just making a model of it, right? However, understanding that something's broken sometimes requires a little bit more thinking. So here's on the left-hand side, I did a search for it with how contagious is bronchitis? And the answer is people who have chronic bronchitis or asthma sometimes develop bronchitis. It is not caused by an infectious virus, so it's less likely to be contagious. It says that right there, right? And if you click on the link, it takes you to that webpage, which is the Mayo Clinic, highly reputable, highly credible place. And then it says in the answer, is acute bronchitis contagious? Yes. Oh! That should worry you because the summary up there says it's not, but the web page itself says yes. Okay. Thing one for the foreseeable future that you need to know is anytime you get an AI response, you got to check it. You got to check it. I know you hate fact checking, but you got to go and check these things. And you know, here's another case. Google Maps pops up an alert to leave for your the hotel reservation you've got in Davis. But what Google doesn't know is I canceled that reservation. So here's a fundamental problem for AI systems as they now exist. Fundamental problem. The real world and updates to the real world and the model may not agree with each other. So remember the problem with the map, Zurich? The model does not align with reality. In this case, I called the hotel and canceled. So I didn't go through the Google bot to cancel it. That's the only way Google would have known. Deep problem. So this is called the frame problem. When things change, what parts of your AI model do you need to go and update? The frame problem. And it happens everywhere. That's a category of failure. Here's another category of failure, what I call ensemble failures. So ensemble failures is when you've got an AI system making recommendations and it actually ends up influencing a bunch of people simultaneously, coordinated as an ensemble. So here I am driving down the 405 freeway in Los Angeles. Okay, I'll have to tell you a story. I'm driving down the freeway in Los Angeles. This is the 405. And it's like this, very busy. And my Google Maps thing says, you need to exit now. I'm thinking, I'm still 50 miles from my destination, but sure, I'll exit, whatever. I will follow blindly, whatever it does. The 4 cars in front of me also exited with me. We were a pack. We were a little pack of drivers blindly following Google Maps. We all exited the freeway together, leaving a big hole in this traffic stream behind us. At which point Google Maps said, get back on the 405 freeway. So we were an ensemble being directed by the omniscient hand of Google Maps. Probably not a great solution. Here's another example. I'm picking on Google Maps because they're the best known to me. If you've been to Los, you might have noticed that Los Gatos, this is a side street in Los Gatos, and during the summertime, it's Google Maps and other mapping services send a whole stream of cars through downtown Los Gatos. The Los Gatans hate that because it takes their nice, quiet little suburban village and fills it up with people trying to get to the beach in Santa Cruz. So this is a bug because there's a failure, because you're having all these coordinated actions happening together, driven by an AI system. You're getting this aggregated failure mode. Here's another one. I'll only do one or two more, then we'll move on. But here's an interesting model where you've actually got a couple of Waymos stuck, because this is in San Francisco last year, and they were going on the Potrero 101 on-ramp. And you need to know right now, Waymos can't go on the freeway. So traffic control set up the cones, taking everybody off of Potrero and sending them onto the 101. Waymos got there and said, I don't know what to do. Help. And they literally stopped right there. And then somebody had to come and bail them out, basically. That was a problem because the San Francisco traffic control did not talk to Waymo and say, hey, the model just changed. We had to close the on-ramp, this off-ramp. So you see them trying to negotiate and figure out how to do it, and it was a problem. Whenever you deploy large numbers of users or robots or Waymo cars using a constant common control system, you have to think about ensemble failures. You have to realize that this could be a problem and what you should do about it. Okay, another category. We talked about ensemble, various kinds of things. We talked about frame problems, recognition failures. Everybody, I think, knows that there are cop cars driving around with little cameras that have license plate readers on them, right? Anytime you go in and out of Portola Valley, Woodside, you drive your car through a license plate reader, and it checks to see whether or not that car was stolen, et cetera, et cetera. This is one from Britain, where this poor woman, you see on the right-hand side, the camera saw that image and said, hey, wait a second. We're going to give you a ticket for violating this ordinance here. So if you see here, it says, you must not ignore this notice or pass it on to the driver. Let me give you a close-up here. She's probably not violating any traffic ordinance. And the thing to know is, in this case, the image reco, the OCR, the optical character recognition, translated that into that license plate. See the resemblance? It saw the word knitter and said, oh, that's KN19TER. And so it sent this ticket to these two people on the right-hand side. Took forever to debug that because of OCR failure. Heuristic for designers of these systems allow people to question the result and give a reasonable compliance or fix-it strategy. How do you do that? So let's spend a couple of minutes right now. I'll give you 4 minutes. So it's 11:11. So we'll go to 11, quarter past. Discuss with your neighbor, can you think of any failures of AI systems that happened to you? And on a scale from benign to devastating, how would you rank them? And can you come up with a couple of examples of failures like that? And then talk amongst yourselves to figure out what could you do to forgive or forestall these kinds of failures. Okay, go.
Yeah, no, it's just like.
All right, folks. All right. What do we got here? What have we got? Anybody have a good, how about a benign story? A benign story of AI failure? Anybody? Okay, left side. Okay, you got one.
When we were designing the car, we both had the issue that it would just randomly duplicate text, like, you know, classic at the end of the line. And, so
Oh, right.
it would do something like that.
And so which, when you were doing what?
For this assignment too.
Oh, I see.
Yeah.
I see. Yeah. Oh, I see. Putting the same word beginning and end. Yeah. Yeah. That's not a devastating error, but annoying. Yeah. Yeah. Anybody else? Yes. Yep. Yep. Right. Okay. Code failures. And you've got one? Yeah. That happened to me yesterday, actually. Exactly that bug. I ended up having to refund the ticket. It was a hassle. You had a good story.
Yeah.
Tell me the story.
I was figure out what I needed to change the DMV for my car. And gave me like asked it 3 different times in 3 different days, and every day it gave me a list of things.
That's
The
annoying.
website was very good, so.
Right. But the fact that it would be in flux. I mean, a better answer would be to say something like, I don't know. Here's a list of some things I think you could use, right? That kind of thing. All right. Anybody else? Going once, going twice? Yeah. Great. So there are lots of things that can go wrong when building an AI system or using it. And this is a list, a partial list. This is like the top 5 things, which is the training data, the input data for the actual test case, the relevance of the data, system hierarchy, and I'll give you examples. So in the training data, as you know, these ML models take a lot of data, and what you hope is that everything is categorized or labeled appropriately, right? But sometimes things will be incorrectly labeled, and that will then affect the determination and the way the underlying ML model works. It also becomes a huge problem when you're missing data. This is a super common error where people will build a model, and they don't realize they're missing huge fraction of humanity. And you see this multiple times. So ways to fix this are allow people to actually say that these results are wrong and give that then reinforcement learning feedback to the system from the user, which has its own issues, but nevertheless. And when you find that you've got missing or incomplete data, it has to be able to allow you to communicate that goal of the system to allow that to be fixed. Here's an example. This is training data where what you're seeing, this is actually from a website called, what's it called? Oh, labelerrors.com. So it's got a bunch of labeling errors. So in each case, what you're seeing here is an image, say, of a ape of some kind, and ImageNet thinks it's a siamang, and then these two other systems guess different things. So if that was the training data, then your interpretation of the data is going to be, of the image is going to be wrong. This one confused me for a long time. This one. So ImageNet says it's this kind of dog, who made it on, right? Whereas CleanLab gets husky, Venture, that is human, said it's both. Took me forever to figure out that that's actually a dog. That black spot there is a real dog. So you see, when you've got incorrect training data, no surprise, the AI system performance is not great. Another major category is input data errors. So you're using the AI and you give it crappy input, really crappy data. So you order 12,000 glasses of water. That's probably not a great input to give it. So what happens, and this happens repeatedly, so do not do this in your system. All inputs. Make sure they're consistent and coherent. Check that it's, the user is putting up stuff that's expected. We also want to break habituation, because habituation is when people do things repeatedly. So what you'll see, for example, when you're doing surveys, not my surveys, of course, but ones that you might find online, what people tend to do is called satisficing, where they click A, as fast as possible. That's habituated behavior. You want to basically design the user interface to not encourage that. If you make every item the same, A becomes a very easy option to do. The third category here is miscalibrated input. When the system focuses on something outside of the user's intent, kind of like with the red berry identification problem. It focuses on you don't even know is there. And so it's miscalibrated with respect to your intent. So here's an interesting case. This is on Grant Avenue, not far away from here, where Caltrain crosses Grant Ave. And as you can see, another car has driven onto the train tracks. And the explanation is almost always, that's where my Maps app told me to go. The Maps app said turn left, and I turned left. Right? And I will say there's a couple of things going on here, one of which is people often make mistakes by overreacting. They see the turn left and the turn left, and don't look that there's a train track there. So it really is a legitimately user error, operator error. But sometimes I've seen this happen too, where it says, and the intersection's long gone. So that's a problem with GPS, location identification, all that stuff. So a big question for AI systems is, when you're directing people and their behavior, how do you coordinate in time and space with that? So we also have a category of relevance errors when the model basically gives you a suggestion or recommendation, and it doesn't have confidence, but it doesn't tell you that. It doesn't tell you the confidence level or how relevant this thing is to you. It just gives you the output. So giving explanations, cheat sheet. We are going to come back to explanations in a few weeks. But explanations generated by AI systems are really, really important to help explain what's going on and why this is a relevant system. Okay, we've seen enough of these by now, right? These side-by-side ones, which one do you want? Why would you want the one on the left? Well, I'll tell you. These guys, the one on the left will give you music for your run, and so you can actually say find songs or something. The one on the right says, I don't have any songs, right? It's just giving you an error without giving you positive guidance. This is a subtle point for building AI systems. The user experience has to be accepting and helpful, not derogatory and annoying. So saying something like no playlists yet, it's true. Be proactively helpful. Be helpful. Don't just say, oh, error 33. Right. So here's I worked on a while ago where when you're in Google search and you typed in something like PJ Start Mary Poplet Carp Zebrafish. For very obscure reasons, that actually was a real query I did one day. And what we did is we popped up this kind of interstitial error page saying, blah, blah, blah. We give you a cute little animation and some helpful suggestions. Again, be helpful. You've got an AI system there. You can make that AI system be helpful to people. There's also interesting issues when you have a hierarchy of systems and system components. So for example, a lot of systems are now componentized systems arranged in hierarchies where pieces are doing various jobs and then assembling all of that stuff together, right? And so what we need to figure out how to do is alert people to what's really going on in the system. How often has it happened to you, for example, something breaks? I've got this very fancy refrigerator at home, very fancy. And I open the door and everything's dripping out and the freezer is broken. What's going on? Well, there's a hierarchy of systems here. There's a controller board and there's a sensor and there's there's all these different pieces. And now I have to figure out which one of those pieces is broken in order to debug the system. Same systems. Look at that map for a second. The blue line is the route it wants me to follow. See any problem with this? There's a bunch of turns here that are not necessary, right? So what's happening here is that there's some particular characteristic of the route planning algorithm that says you need a left turn and then a right turn and a left turn to get back on the route. That's a stupid suggestion, right? So what I would love to be able to do at this point is to give feedback to the system saying, don't ever send me somewhere that gets me back to the same place. So, and I don't have any mechanism for doing that. So your AI system needs to take a look at the recommendation and do kind of a common sense filter analysis. And I know I've shown you these kinds of examples before, but this is a good one, a variant on that theme. Here I'm searching for my daughter by a lake. I get a bunch of pictures. Awesome. I think I can show this in class because it worked. However, there are silent errors. I happen to know that that's a picture too. Why isn't that in the return set? There's no way for me, I just think 30 minutes for this. There's no way for me to give Google Photos a query and get that picture on the left, even though it's clearly my daughter by the lake, by a lake. It's an interesting failure mode. It's not showing you an option which should be in the option set. It's a silent failure. How would you know? how can you signal that I found an error? Currently, there's no way to do that. Okay. In this category of distinguishing errors, I'll pick on a different system now. Yeah, question. Yeah. 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 So saying this for the video, the question is, if you've got one of these situations like this, how do you signal it? Do you give more information? And I would say, yeah, but. And the answer, the reason I'm saying yeah, but is contextually important, because suppose I've got 1,000 different things that it could be. Showing 1,000 different options isn't helpful, but showing 2 or 3 of the most likely options would be helpful. So you want to contextualize the kind of feedback you give, or the feedback that you can give to the system. So show the 3 most plausible options. So another way to interact with this would be to say, and show me the next couple of images that you're not showing me now. What are the, because you know internally, we know internally because we're the literati of the AI world. We literati know that there's this continuum of these things. So what I'd like to be able to say is show me the next few. Okay. This is just a standard music recommendation algorithm. And I said, show me music by Bach. And what's the problem here? First off, the first hit is music for babies. I really don't want music for babies. Thank you very much. This is a random excerpt from a major work. So there's a big work, and it's randomly took a chunk out of the middle. Not what I want. A discerning classical music listener, right? And it's giving me kind of low quality results. Or that's the 3rd time we've seen this piece in this list. Or that's not by Bach. So it has failed the ultimate filter at the very beginning of this thing. And there's another one, another random excerpt from a random work. So from my perspective, this is a very low quality set of results. Failures because it doesn't appreciate the kind of person I am, the kind of listener I am. It's giving me random pieces, and it's giving me things that don't even fit. Again, the question comes back for us as UX, UI, AI designers, is how do we get feedback to this? I would love to be able to do that. I can't find it. When you build your AI system, give people affordances to give feedback. That can be super valuable for the development of your project. We've talked before about vigilant tasks, and this is an image. I did not take this picture. This is a picture from a police report about somebody who's literally asleep at the wheel. This is going down 280 at 70 miles an hour, and these guys are just zonked out. As you know, full self-driving mode requires that you take over control and you get 3 seconds. There's no way that guy's going to wake up in 3 seconds, right? If it suddenly says, hey, you need to take control. Vigilance tasks are something that people are terrible at. You need to know that. Just write that on the back of your forebrain. People are terrible at vigilance tasks. So you need to figure out how to work around that. And so here's a really nice a chart showing how long it takes for somebody to recover from something like being in the middle of a vigilance task. And so the quote here is, to the degree that vigilance is required of automated vehicle drivers, performance errors and associated safety risks are likely to occur as a function of time on task. So the longer it goes, the worse you get. You're not going to fix this. Just because you might think you're a careful and attentive driver, you can't escape basic cognitive psychology. Now, this comes under the heading of attention management. As UX designers, as UX builders, an important part of your task, of your professional task, is to manage attention. Look here, look there, don't look here, whatever the task is. whatever the design is, you are implicitly managing attention, right? So let me give you a great example of this. So what I want you to do is look at this set of cards. I'm going to do a little magic trick for you. I want you to pick a card, any card, remember it, okay? All right, you got it? Now, I just removed one card. I removed your card, right? How does it work? The answer is that I remove all of the cards. They're all face cards, but they all have different values. The King of Diamonds, it's not in that set. The Queen of Spades, not in that. You see what I'm doing? They're all different. You have to notice that that's the kind of thing that can go wrong. If you overwhelm somebody with overchoice, they will not understand what you're presenting. So the delta between that and something else can be used as a basic for a magic trick. Now, this becomes really important when you're trying to do things with image and image recognition and labeling. So in adversarial image recognition, that is where I'm taking an image and trying to get my TSA image classifier to misidentify it. It turns out it's fairly straightforward. There's the paper, you can go read it. It's fairly straightforward to take an image, modify it slightly, because I can't see the difference between that and that. But you can modify the image recognition properties of those images, so it will say, oh, no, that's not a cat, that's guacamole. Or, that's not a turtle, that's a rifle. Same thing, same thing's going on. It's possible to mess up the attention of the image reco algorithm. Okay, getting close to the end here. I want to talk, we've been talking about failure modes, ways to remediate those failures, and different ways of giving feedback to AI systems. You will hear a lot this idea about the alignment problem. The alignment problem is basically how do we get your AI system and you to agree on what that thing is supposed to do, right? So there are a couple of ways to do this. Basically, it's trying to get people to articulate what their goal is, the system to give you feedback and say, this is really what you mean, right? Because one of the things that AI systems are perversely good at is finding alternative solutions that you would not have thought about. So reward hacking is basically when an AI system finds a loophole, finds another way to satisfy your goal, your stated goal, and causing unwanted effects. Right? So there's we will see this all kinds of places. I have of reward hacking. Has anybody seen this? This is El Cordoba. Spell correction. We've talked about spell correction before. You know how it works. Little AI model underneath. But I want you to watch this video. It's a short video. Take into account habituation effects, user expectations, and the use model. Okay? You see the point, right? This is a case where getting the reward hacked is, one of those things, right? Ducking. You just can't beat that. So here's a case. this is operator error, but it illustrates exactly this sort of misunderstanding of what the system is doing. So I'm in Columbus, Ohio, a couple of years ago, looking at the map, and my query to Google Maps take me to the international airport near me. That's my query in blue. International airport near me. And it gives me directions to Rickenbacker Airport. Cool. So I'm up in Columbus and I drive down to Rickenbacker Airport and I get there. It is Rickenbacker International Airport. That's what I asked for. But I get there and it's a single strip with about 5 on it. And yes, it technically has a regularly scheduled route to Canada. That's why it's International Airport. That's not the one I wanted. It's a misalignment problem. I said one thing and I didn't know. I should have been going to John Glenn, which is in the upper right corner. John Glenn International Airport is the big airport with 747s and all that stuff. I was not aligned. And the AI system was not. What it should have said was something like, are you sure you want to go to a tiny little airport? Giving context-appropriate feedback to help me understand the misalignment between what I'm saying and what the system is doing. Okay. I'm sorry to drop all this bad news on you, but here's another source of errors, which is model drift. Now, we all know that when you're building an AI system, you're going to build a model, train it with a whole pile of data, and then you're going to have this fully functional, wonderful, time constant model, right? Well, let me tell you, models need updating. Models need updating. And the moment you stop updating your model is the moment it starts to become irrelevant. If you're building a large language model, you might spend $1 billion building your language model, and the moment you're done, it starts to decay. Oh, it'll run just fine, but the world moves on. And the world has data that you need to incorporate. So, question for us is, how do we do that? So here's one piece of advice. Drop the illusion of perfect data. Do not tell your users that your model is if it isn't. Be sure they know what for example, is now called the system knowledge cutoff date. The model was built on this date, knowledge base is up to this date, anything else has to be added into it. So people will understand this if you tell them, if you give them a way to find out. And so we live in a world where, for example, a few years ago, Google built a thing called Flu Trends. And Flu Trends took data from Google Trends and Google Queries and made this beautiful model that could predict with high degree of accuracy the number of flu cases by place in the United States. And you can see the CDC data in gold tracked the blue data from Google really, really accurately. It was awesome. Paper in Science, paper in Nature, it's brilliant. Now, the reason the blue thing is a little earlier, because it could actually predict where the flu trend, the actual is going to go. This is great. But what happened? So this is fabulous work. It's very accurate. However, we started getting things like this, where the model, the flu trends model, was not aligning with reality. And there were multiple papers that came out that saying, oh, this is a completely broken model. You actually can't do it. Let me tell you what really happened. The guys who built the model, they stopped updating the model, but the model continued to run. It's a process somewhere on the internet. And so the model was no longer updated. If your model doesn't get updated, the predictions will be bad. And so Peter has a comment.
There's a lot of stories on why that failure occurred. I definitely agree with that.
But there's more.
The main issue was that it wasn't being maintained. It did something else.
Yep.
I think another big part was that it was trained on web search data, and the web changed. Right. So this was right about the time that Twitter was becoming more important. And so the types of queries that have come to Google, many of them were now switched over to Twitter. People saying, hey, you know, are all your kids sick too? And that change was not reflected in the data.
Right, right. The deep point here is Peter, and my comment, is that the underlying basis on which these things were being modeled changed. Both the model and updating, the sources of data drifted over to another place. And so I want to tell you, if you haven't heard this yet, George Box, famous statistician, said all models are wrong, but some are useful. And my corollary to that is for some amount of time. For some amount of time, they will stop being useful. Reality moves on. So what do? Told you, create opportunities for feedback, provide paths forward from error, return control to the user in a graceful way, have a clear communication hierarchy, and find ways to avoid misalignment. And I want to close with a couple of thoughts about trust. So there are 4 key factors to trust. If you have this AI system, you better trust that it's going to tell you the right mushroom. Okay? Have a great trust reputation, shall we say. And when they give you instructions like this, they're not enhancing the amount of trust you place in them, giving you obscure, difficult to follow instructions. You can lose trust in your system, in your company, in you, by doing complicated, weird things like this. Another one is trust is based on a set of continued experiences over time of the system. So this came out in Cyber News in July, where Replit AI coding tool wiped out a production database, making up 4,000 users, and then lied about it. So this is one of those cases when you really want to check your data and back up your files. Back up your files, back up your database, because there's a really interesting story. You can go follow it on Twitter. The CEO, to their credit, the next day and says, oh yeah, we got to fix this. It's a bug. More importantly, it's a failure of the AI model. Okay. So a third property for trust is consistency. So we heard about the DMV problem. You kept getting different answers every time you tried it, right? Here's an example where this is actually the data from your spreadsheet about your AI uses. So I wrote a very simple piece of code that said basically summarize the text in this, summarize the text over here in, I'm sorry, this is the tool you use, this is what you said, this is the summary. Okay? Notice anything odd about it? The last 2 rows have a different summary. How could it have this different summary of the same data? It's that same, it's the DMV problem. It's instability in the outputs. I've got, you thankfully put in hundreds and hundreds and hundreds of these tool and short description of use. And so I ran this summarizer over all of it, and I got vastly inconsistent data. Roughly half of the YouTube, where somebody wrote recommendation algorithm, half say algorithm and half say recommendation. We will talk in the future about using AI tools for doing user experience research. Remember this. Remember this. Okay. And consistency. Tools develop trust in people, or people develop trust in tools when they realize that they can get the thing to work consistently. I just showed you 2 examples of inconsistent behavior. But there's also consistent behavior across a. So Google has this product called Discover. It's been around since 2016. It was only released onto desktop in April of this year. And I still haven't made it work. That's a separate problem. Nevertheless, if you do as I did, go to the the desktop version of Google and say, can I use Discover, Google Discover tool? It will never tell you you can't. It will just fail silently. So you have inconsistency, which is, and credibility is determined. I can give you a whole talk about credibility. But I want to point out one thing. If you say stupid things, you don't enhance your credibility. You do not enhance the trust that people have in your product. So Grok was famous this past year for saying a bunch of really silly things. In particular, I like this one. Limited evidence exists. I visited Epstein's New York. You, Grok? Really? I don't think so. And so that is not enhancing the trust that anyone would place in this, right? It's kind of crazy. So how much does all this stuff matter? I would say the design of our AI experiences absolutely is critical. We need to pay attention to all these different failure modes and design our systems, our tools, to not those pitfalls. So I think open issues for us as research is, what's a great UI pattern that enhances alignment? You're starting to see research in this, but it's still an open question. Or something we see a lot of is the necessity or the requirement to show signal uncertainty or confidence levels, and nobody's got a good solution for that yet. So if you're looking for a project, keep that in mind. There's our question. "101 slides. How did we get 101 slides? Ay. All right. I will be sending out a little summary of the responses you all gave to the ethics survey, because you might want to see that. It's really, I think, quite interesting. And we will see you next week.